moving on to the transmitter now on the, moving from the transmitter to the receiver on the Realistic TRC1002. So again, with the manual in my hand here, the first thing to do is to align the receive oscillator. So these are crystal controlled. I've said to you the channel A receive crystal, use the yellow tool, you'll be able to see it better, is the one to the right, and the channel B receive crystal is to the left if fitted. And so these come with a single channel as they were sold. So we're going to adjust receiver 4. Now the instructions here are: connect the vacuum tube voltmeter, or in our case FET voltmeter, and a frequency counter to pin 2 of IC1. Well, IC1 is the MC3357 IF subsystem, because with this being crystal controlled, you can't set the frequency with some kind of master oscillator. It's not synthesized, and so the crystals have to be adjusted individually. Now in commercial radio we would tend to use a little secondary signal generator with the IF frequency. In this case it would be 455. Sometimes it's going to be 10.7, sometimes it's going to be 21.4. But the method that they've come up with in the Realistic Service Manual is to do this with a frequency counter. And so we will do that as it says. Now I've already got this ready. I've got a frequency counter on the VTVM, and I should have a frequency, because if we're taking the IF off the frequency, because I'm on 27.79125, and so subtracting the 455 IF, we're looking at 27.33625, and my frequency counter's reading 27.33574. So I'm on pin 2 of the IF chip, and so I'm now going to adjust the trimmer, which is CT1, which is the one next to the crystal there in the receive section. And we're looking for 27.33625. Which I now have. So that's set that up. So that's the receive now, spot on frequency. In fact, I can hear how the signal generation has come through better having done that adjustment. So that was quite a way out on receive. And so this company has 8 of these radios. They're all in for service this week. So they have them serviced about every 3 years, and they obviously feel it's worthwhile retaining this type of equipment. So we've covered that. So now we're supposed to be on test point 4, and test point 4, which I'll just, is where I've got the red crocodile clip, which is going to our external speaker. Now what you should really be doing is disconnecting the internal speaker, which means taking the printed circuit board out, which of course is a big faff. So we've got the wrong kind of load, because we've got an 8 ohm load with the test equipment, we've got an 8 ohm load with the internal speaker, and of course Ohm's law tells you that's now a 4 ohm load. So I'm keeping the volume low, because the last thing we want to do is to damage the audio output amplifier chip. So I'm keeping that volume low. I'm going to be very careful because the impedance mismatch there. So now we're going to go through L1, 2 and 3, and we'll be using our synad meter for that. L1, 2 and 3. Well, they're here. There's L1. There's L2. And there's L3. So we'll do that right away. I've got the signal generator on a suitable signal. That's absolutely fine. There was really very little difference now having done that, so which proves it was the alignment was correct as it was on those. And then we're going to move over to L5, which this is, as I said before, this is a single conversion receiver. It's not like the normal double conversions with the more adjustments. It's a much simpler arrangement and of course cheaper arrangement. Now we need to put a hefty signal on to do L5, which is the detector, and L5 is inevitably next to the IF subsystem chip, and it's there. There's L5, which is the detector. I'll put a big signal now on the generator. Instead of turning the volume up like I normally do, as I said, I've got a mismatch because of not wanting to mess about by taking the printed circuit board out. So I'm now looking to get the best. Now I've put a bigger on the oscilloscope. We'll just we're on the left-hand oscilloscope. I'll just make that so you can see both things at once. Oh, the mixer's not set up right. Well, we'll switch it back very soon then. So left-hand oscilloscope. I'm looking at the maximum there. You can see we can take it to absolutely nothing. I'm also looking at the audio output, and there we have it. Yes, that's peak. I'll switch you back to the other picture there. So that's the receiver so far, and then we need to adjust the squelch. And surprisingly, on a simple set like that, the squelch is adjustable. It's VR3, and VR3 is the vertically mounted preset, which is under the antenna there. Now the audio output IC is a single inline one there, and the squelch control preset is just there. But before we start adjusting it unnecessarily, we'll see whether it performs how I want it to. So I'll just turn the squelch up. I would like it a bit stronger squelch than that. Now this is going to be quite a faff. Let's try to turn this around without coming disconnected from the test instruments, so I can get to the preset. There we go. Now make sure that it's still, yes, it still comes in at a sensible level. Now we'll set the radio for minimum squelch. So it's such a faff working on sets like this. So there's minimum squelch. As a sensitivity check. And for a single conversion receiver, that's quite reasonable. So I'll turn the signal generator off, set the squelch for minimum, which is, there we are, switch it back on, and that's tracking fine. So that concludes. So we can disconnect the test equipment and put the radio back together. Now we have it. Realistic 1002 from 1983. I will just backtrack on check the frequencies correct on channel B on this bit off video. Now I've got 8 of these to do, so that's the first one. So I hope that was interesting on such an elderly set, but it's in such good condition. They really do look after these.